Okay, we're back and we're looking at the prints again. Just to summarize a little bit, what we talked about in the last session was the general layout of the working drawings and the general plan types. And what we're going to go ahead right now, and you can see I've already started a little bit with laying it out, is we're going to talk about the plan types that are specific to the electrical section. Okay, so some of the plans are the same. Okay, so in electrical, you'll still have some of the general plans, but in addition, we have some sort of plans and sections that are very distinctly for the electrical, and most of the sections may contain some specific information like that. But for the electrical, there are a selection of plans that we need to be aware of, and so I'm going to go ahead and I'm going to start itemizing those for you. Okay, let's take a look. So to begin with, the plans that are general plans that still apply very much are the site plan. Okay, so site plan. So you'll have a site plan that will be, in the E section sheets, and it will show the same site as it shows for architectural, except on this site plan, instead of showing maybe the parking lot spaces and where the sidewalks are, this one will show where the EV chargers are and where the transformer, the main transformer is for the building, things like that, parking lot lighting. So the site plan, but it will be specific for electrical. Also floor plans, okay? So floor plan, another general type, but we'll have very specifically, we'll have floor plans that contain just the electrical equipment, power, lighting, those are the main ones, power and lighting plans. And then following that, after the floor plan, anytime that you have some layout of electrical things, there becomes necessary to have a section. So we'll have actual electrical section drawings, sometimes of equipment like MCCs, things like that. Okay, so a section plan. So an electrical section plan, and also very important, details. So we'll have electrical detail plans. Now, as you can see, this first row are kind of these are sections that are common to probably the same type of plan as you would find in any other section, but they are, of course, they have different information that is relevant to the electrical work on them. Then, in addition, we have some more plans, and these ones are really, really specifically electrical. So let's start over here on this end. And the first one that I'm going to put up is something called, and it's something we're quite familiar with. You will find, particularly in installations where there are motors and motor controls, you will find wiring diagram plans. Okay, wiring diagram. Oh, I gotta write that smaller. Wiring diagram. So you'll actually find specific information that shows how the wiring diagrams are, to be set up for all of the different motors and things that are involved. Another thing that you can see, and a little bit different, of course, the wiring diagram usually shows the location of equipment and the routing of conduits and things to bring wiring to them. A schematic is actually usually more just electrical flow, okay? Schematic. So you can find both of those types, wiring diagrams and schematic plan or schematic diagram plan. And you can find whole pages with, if you have a variety of different motors, some of them will utilize one type of control circuit, some another. You'll find basically a whole sheet that just shows the wiring diagrams or the schematics for different pieces of equipment, part of the electrical drawings. Okay, now another one quite often used, especially when we look at service equipment. So everybody likes to know exactly what's going on in terms of the incoming, what is the incoming line voltage? Where is the main, the main transformer? What are the voltage levels? And how does it then get split up? And so if you take and you just draw a diagram that is called a single line, and that we've talked about that in previous sections. The single line diagram, very good at describing how the service is broken up, any changes in voltages, and what the main panels are, and everything like that. Now, the interesting thing about a single line is it shows how everything breaks down voltage-wise, but it gives no indication as to physically where the equipment is. Okay, so the diagram that will show that is not a single line, but it's called a riser diagram. Now, a riser diagram will actually show that that the main service comes in, and maybe it's on the main floor. Maybe there's a house panel in the basement. Maybe there are different. Maybe there's a motor control center in the basement, and it basically shows by elevation in the building where all of the different parts of the service are. And so a riser diagram, lots of good information in terms of physically where you're going to find these pieces of the system. Now, a couple of more, and I put them here just so we kind of keep them closer to their main sort of their parent types. This one is called a block diagram. Now, a block diagram is actually similar to an elevation, and interestingly enough, there are not very many elevation drawings, and that's why I didn't include it here as one of these sort of types. Electrical equipment doesn't contain sort of the classic style of elevation where you see a view of the outside of the building, this and that, but this block diagram is actually an elevation diagram of essentially, like let's say you take a wall and you say, okay, this is going to be the main disconnect, and then I'm going to feed into a splitter that's going to be here, and then I'm going to have a disconnect here and a disconnect here, and I'm going to have a couple more down here, and the floor is down here, right? And this one is going to go disconnect, and then there's going to be a panel here, okay? And it'll actually physically show you the layout on the wall, okay? So this is an actual layout. So a block diagram, particularly in electrical rooms, MCCs, will show physically where all the parts and pieces are going to be placed and how they're going to fit together. Now, the last one, also interesting to look at. It's a little bit like a floor plan, but it's a reflected ceiling plan. And this is used for lighting, okay? Reflected ceiling plan, and it's used for lighting. Now, the interesting thing about this one is that if you take a plan that was a floor plan, like this, and you say, okay, there's an entrance here, and then there's a hallway here, and then there's a boardroom here with a door on each end, okay? And here's the boardroom table, like that. So a floor plan would show you where the doors were, okay? The door swings, probably, stuff like that. And, the dimensions where the walls are and everything like that. But what a reflected ceiling plan is it's like, imagine that you covered this whole surface with glass. It's like a mirror, okay? Mirror. If you made the whole floor a mirror, what would you see? So you go, oh, so I'd see two large, fancy sort of fixtures above the boardroom table. And I would see, in here, I'd see a bunch of lights laid out like this. And in here, I would see, this, maybe some fluorescence here. So what it does is it shows you what you would see if you were looking at the floor and it was a mirror, okay? Reflected ceiling plan. And what's also very often shown on these types of plans is, just for instance, it's a little bit of a crossover of information, but let's say that there's a diffuser for the air handling system. So you need to know where the diffusers are and things like that so you can work your lights around them. So sometimes there's a little bit of additional information, particularly if you had an architect that's really good with coordinating between different trades. He'll probably put some useful information from another discipline onto the electrical just to make sure things go better. Okay, and that's, so that's always nice to see that. So the reflected ceiling plan, primarily a lighting plan, okay? And the block diagram is normally pretty much primarily a service equipment type thing. This is where you see it the most often. Service equipment, or it could also be MCC. So if you have a motor control center, you'll also see it used for that, okay? So we have then our main types that are, kind of, they're specific to electrical, but they're very common types to the general types. And here we have the specific ones: the wiring diagram, single line, block diagram, reflected ceiling, riser, and schematic. Now I just want to show you in here, if you take a quick look in the guide, it's page 26, shows you the site plan, okay? Page 26 is a site electrical plan. And you can see on here, it actually shows the lines that show where the EV chargers are. It shows up in the, I believe it's the northwest corner, you're going to see a transformer, pad mount transformer, and various bits and pieces of information that apply to the electrical. 27, page 27, that's just a power and lighting floor plan. Power and lighting floor plan shows the receptacles and where the feeders come from, things like that. This next page, quite interesting. This is a section, actually, a section drawing that I found. This is actually the kind of an antique drawing, a vintage drawing, and it's for the Bunsen powerhouse. Okay, and it shows, it's a section view. It's like cut in half, and it shows the location of the transformers, the actual water, the actual turbine where the water goes through, and the high tension area in the top. So very interesting to look at that powerhouse section. That's a section diagram. Page 39. Now this is really, if you look at it, it's kind of like an elevation because you do see the side view, but an elevation, here's the difference. This drawing on page 29 would be classified as a section primarily, and it's because you're seeing a cutaway of what's going on underground, the concrete ballast below the EV chargers, and shows you how the conduits enter and stuff like that. So even though you may sort of like, oh, it's kind of like an elevation because I can see the brick facing on the building, really primarily it's more of a section, okay? Flipping to the next page, I've shown you an example of a block diagram. This is an MCC, shows where the cubes have to be laid out, where the main switch is, and everything like that. The next page, an electrical detail. So this shows, actually this is one of the power panels that we're going to look at and explore. This drawing on page 31 is from the DFO prints. So this is a power panel out on a wharf for the boats to plug into, and you can actually see it shows a cross section. So it's kind of a combination detail cross section because you can actually see where the plugins actually sneak in through a space under the cover and then go up and plug in. So kind of interesting. It's got a nice sharp top on it so the seagulls don't sit on it. And next page, page 32, reflected ceiling plan. Okay, so you can take a look at that. 33, the riser diagram. And so there you can kind of see a lot of stuff in the basement on this one. And then as it goes up, different pieces of equipment, panels and things as you move higher. Single line diagram really just shows the power, which disconnects it goes through, which, if there's any variation, any transformer, where the main fuses are, things like that. And the last couple, we're looking at a schematic and a wiring diagram, all right? Now, With all that being said, there's something else very, very important that is included in electrical plans. And this in itself is another type of plan, but what I've done is I'm going to talk about it separately because it's not a classic plan per se where it's just pictures and diagrams of things, okay? So we're going to move these and set those aside for a little bit. And we're going to move these. So we're still looking at the electrical sheets. And now what we have, and there are normally in the plans, now these can appear in the plans or both locations, plans. So in the actual prints, actually let me use the word prints to be more specific, the drawings. These can appear in the drawings or in the specifications. So this next thing, these can appear as pages in the drawings and or pages in the specifications. And this category of items is called schedules. Now, schedules are essentially tabulated information. Okay, tabulated, so tables of different types of information that is necessary, and this stuff is really valuable when you're working, with blueprints. So I'm going to give you a quick list. Actually, you can see it here on page 37. These are the types of schedules that you will find. And often types, fixture, general notes, and transformer schedules quite often as well. You'll find these right in the plans. Sometimes, depending on the size of the job, you may also find some schedules tucked away in the specifications. So here's the types. And we have fixture schedules, which show essentially the lighting types, voltages, locations, like which rooms they're in, sometimes reference to which sheet that the fixtures will appear on. Panel schedules. Panel schedules will show essentially, the panel names, number of spaces, and all that type of thing. I'm going to go over these in a little more detail after. I'm just running through these quickly. Receptacle schedules. Transformer schedules, particularly in larger jobs where there are multiple transformers to be installed. That's an important one. Motor schedules, industrial type things where you have a number of motors being installed, motor schedules. Now, general notes. And in the end, this is just to continue this idea, finishing schedules and door and window schedules. Now, those schedules per se, we don't necessarily have as much to do with, although sometimes we need to cross-reference to them. And those last two are normally found with the architectural section, okay? But the first, any of these first ones here, fixtures, panels, receptacles, transformers, motors, and general notes will be found. It'll be general notes to the electrical sheets, and they'll be actually in a schedule, okay, in a schedule format. So let's go ahead. What I want to do then is I want to go over in a little bit of detail some of the information that you're going to find in the schedules. There's some important points in there. So let's go ahead and I'm just going to take a look at that just in a moment here. All right, each one of these schedules will contain different types of information specific to the type of device that it is. So I just want to give you a quick idea of some of the important points. And so I'm going to go through them one at a time. Lighting, sometimes called fixture schedules or lighting schedules. Some form of this is included in almost every set of plans, and so there's plenty of information that is necessary. So we typically have the type. Okay, what type of fixture is it? And so that's going to be one of the key points. What is its mounting style? Is it flush? Is it ceiling? Is it surface? Is it outdoor, indoor? what is the mounting, basically the mounting style. Another interesting piece of equipment, almost always included in a schedule per se, because here you have a very organized way of putting down some key information, and it's size, lamp size, and quantity. So, okay, this lamp takes, it takes 50 watt replacements, and it needs 3 of them. So when you take the cover off, you're going to have 3 of these guys ready to replace into there. Okay, so lamp size and quantity, and dimensions. Okay, the actual dimensions normally included. Very specific information. Interesting point. A lot of times lighting can be, especially if it's drop-in lighting that moves into a suspended ceiling and things like that, very, very commonly includes weight information. And as you know, sometimes you have heavier fixtures, you actually have to put, you have to supply, safety cables on them and things like that. So weight. Often included are the location. In other words, where on this job site. So in other words, which sheet am I going to look at for where these things go? Okay. Voltage normally included, the voltage of the fixture. And the last thing, not least, of course, quite often, the actual power demand of the fixture. So lots of information, and this information is it's useful during the installation of the project. But for instance, the things like the replacement, like the lamp size and quality, that's information that's used. It's drawn from the as-built for maintenance in a lot of cases. Somebody will come along and they'll go, oh, I have no idea what's in there. Maybe I got a set of prints, and they go back and they look, and they go, oh yeah, that should have this. And so they're able to get the replacement lamps and things that they need, and then they carry on and do the repair. Okay, so common information that goes into a fixture schedule. Now, panels. Well, panels, particularly when it comes to, if you look at a riser diagram, usually on a riser diagram, it will show panel names. And so each panel has to have a name. So a specific name, and that's the only way you can keep track of which circuits have to be fed from that panel. So panel name, very important. Ampacity, the total ampacity of the panel, okay? That's a piece of information, very important, and should be included in the panel schedule. Number of phases, okay? Number of phases. So single phase, 3 phase, what is it? Number of spaces. Now, I say spaces because there are spaces, actual spaces, where you can fit a device onto the bus bar, and they can be quantified by a definite number. Now, in fact, and what happens in many cases is people design breakers that will provide 2 circuits from 1 space. And so we can't, you could actually increase the number of spaces that could be fed from, the number of circuits that can be fed from a panel, but you can't increase the number of spaces. Okay, that's something that comes from manufacture. So the number of spaces is given in the panel schedule, okay? Dimensions, panel dimensions. And this is pretty important when it comes to just installing them, whether they're in brick, in mortar blocks, or in some other form of construction. You need to know the size. Are they flush mount or are they surface mount? So mounting style, and that's something that will be included in the schedule. Mounting style. Now, that pretty well, that's pretty much in terms of the schedule. That's the the sort of the key information that would be in the panel schedule. And what's also quite often included for, if you've ordered packages of panels for a specific job, what will also be included, and it's sometimes listed in the schedule, is the actual number and size. So when I say the number is how many single pole, how many double pole, how many triple pole breakers do you have, and what are their sizes? 40 amps, 50 amps, 70 amps, 15 amps, 20 amps, what are they? So the number of breakers and the size, okay? And so size is amps and amps and poles. So how many poles and how many amps. And so that's also information that can be definitely included in the schedule. Okay, receptacles, a little bit, a little bit less. Now, it depends entirely on the type of project. If you get into, particularly into, let's say, a small manufacturing facility that you're putting together, anything that's, light or if it's heavier industrial, you can have an immense amount of different power outlet receptacles in different locations. And so if you have a schedule of that, then you can literally look at it and say, okay, what is the ampacity and voltage of the receptacles? Ampacity and voltage. As many of you know, receptacles come in, like, there's got to be thousands of different configurations. And so you need to know, is it straight blade? Is it twist lock? Is it weatherproof? Is it, what is it? Because you need to be a parts guy. Get your catalog out to figure this one out. But the schedule will help you with this. You'll say, this is the ampacity and voltage, and these are the model numbers. So you need to have actual model numbers of the receptacle, okay? The grade is also important. Are these hospital grade, sometimes called spec grade? Are they, are they for life support? Are they just general purpose? What is the grade? Okay, so that's something that will be listed. Location, where are they going to be placed? Where are the receptacles going to be placed? And the other thing is, quite often included here, is the panel, and we're talking about fed from. So in other words, what panel is this going to be fed from? And usually includes right down to the circuit number or numbers, okay? And so plenty of information that can go along with receptacles. Now, transformers, interesting, a little bit different kinds of stuff. Transformers also have a name, usually a name or a number particularly, some definite ID. So I'm going to say ID, probably a number. And so that will be in the schedule. Transformers, you got to think, okay, there's got to be a KVA, right? KVA rating of the transformer, that just makes sense. Now, as soon as we start talking about a transformer, we're going to have both primary, usually primary and secondary voltages. And that will be shown in the schedule. Number of phases. Number of phases. Is it a single phase? Is it a three phase? What are we doing that way? Here's an interesting one, not so much for transformers that are inside, but definitely comes up. They have what they call dry weight. And you go, well, why is it called dry weight? Now this has to do with where you're going to mount it, how you're going to support it, things like that. But what can happen with a transformer is it can be shipped dry. It can be a wet type transformer. In other words, you're going to have cooling fluid in it, but you don't ship it with that, obviously, because of weight restrictions. So you have dry weight, and then they will also include what will the weight be once it's filled with coolant. Okay, so you'll have dry weight and basically full weight. Dry weight and full weight. And sometimes also listed in this schedule will be mounting clearances. Now we know that this is something that's stipulated in code, of course, but code is the minimum clearances. What's listed in the code is kind of a minimum standard, and sometimes you know, that would be you know, the minimum sort of thing, but the engineers will actually specify sometimes in the schedule exactly sort of some details about the mounting. And so that kind of gives you an idea what you'd find in the under the transformers. Now, what about motors? Now you can see where there's information that's specific that kind of goes with the different types of machines. So now we're talking about motors, and you know, first thing right up there, horsepower. What's the horsepower of the motor? Or the kilowatts, okay? Horsepower or the kilowatt output rating. And voltage. Voltage and FLA. So the full load amps, volts and full load amps. Number of phases. Number of phases. Overcurrent. Overcurrent type and ampacity. So that's, are we going to use a breaker? Are we going to use a fuse? Are we going to use a standard code fuse? Are we going to use a, or are we going to use a, you know, a different type of fuse, more of an HRC fuse, time delay? What are we going to do, right? And so it will literally list in the schedule. And this is particularly useful for maintenance after the fact, is to find out what was the original design of this piece of equipment, especially if a motor's been running for a few years without much problem. Very, very handy to be able to look at the original documents and see what size of fuses were used, what was spec'd, and everything like that. Now, overload. Okay, so we're also going to include in the schedule overload, type and setting. Type and setting. So how many amps will it be set for? And location. Where are these motors located? And last but not least, and this actually ties together with something that I mentioned earlier. I said that we could have actually, you know, whole, like basically on the plan, as a plan type, will be to show the control wiring. It could be the wiring circuit or actually schematic diagrams of the control for these motors. And so here it will actually list in a schedule. So this could be cross-referenced to those wiring diagrams. And this is the type of control. And so this, of course, will be related to the wiring diagrams and the schematic diagrams that are included. So lots of information, and this stuff, you know, it ties together. And so what you find yourself doing is you find yourself cross-referencing, and when you cross-reference several things together, and all of a sudden you find, it's like when you do a problem and then you think, okay, I'm going to double check that a different way, and then I'm going to double check it a different way, and I get the same answer every time, and you become pretty confident that you've nailed it, that you've thought about everything. And so in the same way, and when you work together, you see all these different areas of the prints, and it you know, one thing confirms the other, and it starts to make a lot of sense. Okay, so just give me a moment. I'm going to clear that board, and then we're going to carry on with the very next thing. Okay, now a little discussion about notes. And so I've kind of left this to the end because it kind of mixes back and forth between schedules and not being on schedule. So it's a little bit of a hybrid thing, okay? Notes, very, very important in the overall explanation that you're going to receive for a set of construction drawings. Now, almost any of the main sections, whether it's architectural, electrical, you know, structural, whatever the case may be, whichever main section, it's not uncommon on the first page to have a schedule or like a table of notes, and there can be lots. You know, there could be only 5 or 6, or they could be 40 or 50. Okay, and those notes are typically what we would call, they're in a table, and we call them general notes. Okay, general notes. So I'm going to put that on this side. This is general. And the idea is that when you see these notes, they typically apply to everything that you see in the rest of that section. So it doesn't matter which electrical sheet you look at. If there's a note in the general notes, it's going to be whenever you see this situation anywhere in these sheets, this note is going to apply. It's a general note. It covers overall everything. Now, so this applies throughout the sheets. Now, move to the other side, and you will also come across something that is all of a sudden on the edge of a page somewhere, there will be a little note written somewhere in a border, or just wherever there's a clear space so that you can actually print something and see it. And then that note will actually have a line. We call it a leader line, and it's a line that leads your eye from the note to the actual item. And the arrow should just touch whatever it is you're talking about. Okay, so these are called leader lines. So you'll see a note and then a leader line that points at something in the actual drawing on that sheet. This is called a local note. Local. And these are one ofs. One of. So that note just applies in that spot. So if you saw something that said, a little leader line that said this door needs to be a 42-inch door wide, and then you turn to the next page and you see another floor plan and there's the same, it looks like the same door, and you go, oh yeah, those are supposed to be 42-inch. No, not unless there's another local note there that says 42 inches wide, the door. So local notes only apply one time wherever they are, whereas general notes apply throughout. So it's pretty good to understand that. And then as you're going through, you can apply the right information in using the notes. All right. Okay, so that's pretty good for notes. Okay, let's go ahead and move on now to the mechanics, what I like to call the mechanics of the actual prints and drawings set, the construction drawings. So there are some things about them that are pretty standard, and it's useful to understand exactly how they go about putting some of these things together. Let's talk about the paper first. Okay, the paper that prints are printed on, first of all, usually a fairly smooth, heavy paper, and it has to stand up in some pretty tough conditions normally. And but the main thing that I want to show you is this. There's a system, and it's laid out like this. Prints and drawings, blueprints are normally landscape. So even if it's a single page, just a single page blueprint for a small house or some small, very, very small project, typically will be, one sheet laid in this way. And what they do, here's how the standard works. They literally go at it like this. This is 8 inches. 8.5. And this is 11. Now that's a standard letter size piece of paper, okay? 8.5 by 11. In the landscape, it's laid in the landscape position. So it's like this page laid this way. And I can see that I made it just slightly too narrow. Okay, there you go. That's your, that's your first size. And this is called size A. Okay, that's called size A. Now, if I take this and I go like this, okay, there's my, and then I put another one beside it like this, that's now two pieces of my 8.5 by 11. So 2 sheets. And by 11. And so if you look at that, this is called the B size. And it's still, you know, this is one sheet of paper, but it's the same size as two of these laid side by side. And so if you look at it, that means that this is going to be 11 and this is going to be 17. So 17 by 11 sheet would be the B size paper, okay? B. Now, if you take that B size that you had, it looked like this, right? It looked like that. And you take and you flip it on its side, so now you have this. Okay, so there's those two sheets. Remember, this is 17 and this is 11, right? And now you add another, so you double it. So there's another 11 and you know, this is still 17. Now you've got actually, overall, you've got 17 by 22. And 17 by 22 is size C. That's size C print paper. Now you're probably starting to figure out where I'm going with this. Now we're going to take that whole thing and flip it back this way. So now it's going to look like this. And this is going to be the next size. And I'm actually going to take, and my sheets are going to be laying this way again now, right? So these are the thin lines, right? That shows the actual single 8.5 by 11 sheets. That's the equivalent. I've got 4 of them here, and now I'm going to add another 4 here. So now I'm up to the equivalent of 8 single sheets of paper. And so if you think about it, this is 8.5, 17 times 2 is 34, right? So that's 34 inches wide. That's the landscape view. And this is going to be 22, okay? And this is actually going to be size D, okay? Now, how many sheets of paper would it take for size E? Well, double, right? So you would take this whole thing, turn it this way, add another 8 beside it, and the larger size prints, like you know, getting into E and those large sizes, are not very practical for most projects. But if you know, if you have prints that have a lot of stuff that needs to go on one page, and you know, so that it does happen, right? They do make prints in those sizes, and they are you obviously need a nice big expensive plan table to look at them on. Okay, so that gives you an idea of the paper layout. Okay, so you get an idea how that goes together. Now, the next real important thing that is part of the mechanics of the drawing set. So the first thing is paper. Okay, paper. The second thing has to do with scale. Now, scale, very, very important part of this subject. So there are essentially a couple or 3 different types of scales that are essentially used. It depends a little bit on the type of plan, what it is you're using, but the first one, if a scale uses essentially imperial, so feet and inches, and fractions. So I'll just give you an example. 1/16 equals 1 foot. Okay. So this type of scale is called architectural. They call it an architectural scale. And we can this is kind of this is an elevated or like an artificial ratio. There is a ratio there, but it doesn't hit you as, it's not a sort of a, it doesn't hit you as a number per se. And so we could actually convert that to, thousandths of an inch or something like that. But in many cases, that's good enough. And these are used for some projects, particularly in areas where metric is not prevalent. All right. Now, the other type of scale that is usually used with very very large scales, okay, large projects. I should say it's a large project, like a large area, but it's actually a very small scale, okay? So small scale, called an engineering scale. Engineering. And these are used typically for things like streets or even highways that run through certain areas. So you could be talking about hundreds of kilometers, involved in the scale of a drawing. And these are usually in scales of 1 to 1,000 up to 1 to 5,000. Okay, so large numbers, but actually very small scale. This means that the actual object on your drawing is very, very small compared to the reality of the actual distance that's involved in out in the real world. Okay, and so that's called a very small scale. Now, the one that you're probably going to come across most often is the metric scale. And most of the prints that you're going to work with are going to be this metric scale. And it's nice because it's based on decimal, right? The metric scale based on decimal. And the typical numbers that you see in the metric scale are nice numbers like this, 1 to 10, 1 to 50, 1 to 100, 1 to 200, and sometimes as high as 1 to 500, okay? But these are the typical sort of construction site ratios that will be used. So this would be a small scale, this would be a much larger scale. Now, if you get down to a detailed drawing where you've got a 1-to-1, we call that a, actual size. And if the drawing is actually larger than the actual item, we call that enlarged size. So that's also possible. Now, one thing that I'd like to mention about this is that what we're really looking here in terms of taking some measurements on a plan is this could be typically this 1 is represented as the unit is a centimeter. So 1 centimeter. So if you look at the 1 being a centimeter, then this is 10 centimeters, 50 centimeters, 100 centimeters, which is, this one here would be basically 1 centimeter equals a meter. This would be 1 centimeter equals 2 meters. 1 centimeter equals 5 meters. And so you can see that those are going to be pretty useful scales for us overall. Now, one of the things with scales that we have to figure out right away, early when we start working with this, is you have to have some way of proving the scale or verifying where you're at. Now, many prints will show something that looks like this. It's a little box. You'll see this put on like this, and you'll see different kinds of shading, but it's not uncommon to see this, and divide this like this. So they'll have it kind of like, it looks something like this. You've probably seen these before. Okay, and then it shows actually the scale. In this case, it says 40 meters. So in other words, what we're saying is on the print, this distance from here to here will represent 40 meters. And the scale is also given, and the scale is 1 to 500. Now, what that means is that if 40 meters, if that's 40 meters and the scale is 1 to 500, how long should I be? You should be able to take your, like just a ruler, plastic ruler with centimeters on it. You should be able to lay it along here. And let's check quickly the math on this. So if you go 40 meters, that's 400 centimeters. So if it's 400, then this should be, if I actually measure this, it should be 8 centimeters long. 8 centimeters. Now, if you measure that bar and it's 5.5 centimeters, you can still figure out the scale of that plan, but there's been some photocopying done and it's changed sizes, okay? It's not accurate. So proving the scale is proving that you can look at this and say, okay, that's supposed to be 8 centimeters long. It is 8 centimeters long. So now I can take my ruler and I can go over to some other, I can measure diagonally. I want to say, okay, I'm going to cut a trench from here to here, and I'm going to lay some cable in it. How much cable will that take? Well, you can just take that, measure how many centimeters it is, run it through, and you know your scale is accurate. We call that scaling the print. So you can actually use the scale to make accurate measurements of whether it's materials, different things like that. Distances that are needed for safety buffers, any type of thing that you need to know a specific distance and it's not listed on the print, then you can actually use it as long as you first check and prove the scale. Got to prove the scale first, all right? So copying of prints is normally, it's something that you try and avoid for a couple of reasons. The quality tends to deteriorate, the resolution goes down, and it doesn't take very long before you can actually have some real problems with it. And secondly is the scale. You know, if the scale changes, you could make, everybody's not aware of that. Somebody could easily do some type of a takeoff where you measure how much tech cable you need or how much wire you need, and you can come up with wrong numbers, and it's going to cost money for sure. So on some prints, on some sets of prints, they show things, and they actually, they want to give you the idea, but there'll be something, and you'll see something that is called, in some corner, sometimes you'll see a box and it'll say NTS. And what that means is not to scale. So in other words, don't try and figure out anything that's going to be pretty affirmative that you're going to be on the hook for. Don't make any important decisions based on the drawing that's shown right here, because it's not to scale. Okay, so you'll see NTS, and sometimes they'll even go a little bit further and they'll put a note, and this will usually appear, this note will be something that will appear usually on the cover page, sometimes in the text box area, and it says, do not scale. In other words, don't try to take a reading on one part and then apply it to something else. So they specifically tell you, don't try to scale this drawing. And usually in cases like that, there are notes that you'll find in the specifications that say that it is the contractor's responsibility to make a site visit and make all of the necessary measurements in person. And so, they don't want somebody just doing a quick estimate, just kind of scaling off and say, it's about that. They say, no, you have to actually make a site visit, and you actually have to check this stuff off and make sure that it's right, okay? So scale, something that we'll need to pay quite a bit of attention to. And when it comes to our sessions, I recommend that you have, a ruler. See-through one's nice, because then you can actually set it up. You can still see the lines through it. And so we will be doing, in some cases, we'll be doing a little bit of scaling. If you have the, hopefully you have, if you have the original size prints, they're scalable, so we can, they're totally accurate, and we can scale off different things. So a lot of the questions that I have will actually require you to scale. So hopefully you can make sure that happens, so that you'll be more accurate that way, right? Okay, real good. We're going to take a look at a couple more things in just a moment here. Okay, the final piece of the mechanics of the drawing set has to do with the types of lines that we use. And so when you look at a set of plans, you need to be able to tell what you're looking at in terms of actually the type of line that you see. And so we need to be familiar with several different types of lines. And so I'm going to show them to you just one at a time. And then I'm also going to show you an example from the reading, sort of the reading handout that I gave you with this. There's some examples in there, okay, in the reading guide. So let's look at line types. First of all, we have what is called the visible line, visible. And this line is normally just a solid dark line like that, and it's used to show the edges of items that are being drawn, okay? So you're drawing an object, also sometimes called a construction line, okay? Visible, or sometimes called a construction line. Now this line, depending on where it's being used, can be lighter or heavier. So usually you use darker lines at the edge to outline items. And but in any case, this would be a line that would be visible. You know, if you were looking at the object, this line would be pretty much visible any way you looked at it, okay? Now, the next line that is quite important to take a look at is one called the center line. Center line. And a center line is a specific line type. And I'll just give you, an example here. I'm going to tell you that here is an electrical panel, okay? And what I'm going to do is I'm going to go like this. And that line, and I'll draw one this way too. When you see that line, it's an alternating sort of a dash and then a dot, just a short bit, okay? So when you see that, a long and a short dash put together actually like that, that indicates a center line. And sometimes you'll see this written, CL, but not always. And so if you don't see CL written on there, just to be aware that actually just the format of the longer space and then the small dash in the middle. So it's long and short dashes. It's not really a dot, it's a dash, but it's a long dash and a short dash. And that indicates that that is the center of that object. Sometimes you'll even see something like this. You'll see a C centered on it. But those C or CL is not necessary to know that that's actually a center line. And it's really just from the arrangement. It's this, right? It's this here. That's a center line, all right? So center lines, important to recognize. Now, let's say that I have an object. Now I'm going to get rid of those two to avoid confusion. So we know what the center line looks like. We know what our visible line looks like. And let's do this. Let's say that I have a, how are we going to do this? Let's say that I show you a roof line, okay? I'm going to show you a roof line here. And so this is going to be a wall coming down here. And that roof line goes over there. Now, so far, everything here is visible, right? But let's say that I wanted to show you this line. This is the line where the wall, basically where the gable end meets the roof, the overhang on the roof. If I wanted to show you that in here, I would have to show it like this. Now, I don't know how well you can see that, but essentially it's a line that looks like this. Okay? And what that's called, if it's behind, it shows an actual contour that from the angle you're looking at it, you can't see. It's called a hidden line. So it indicates, you know, yes, that thing is there, but, you know, you can't see it. So there it is, though. And this is called a hidden hidden line. So we've got the center line, the visible line, and now the hidden line, okay? Now there are some other lines that are pretty important. And so let me go ahead. I'll use this actually as an example. If I wanted to show you what the length of the roof is from the peak to the end of the eave, and I'll show you on this side over here, what I would do is something like this. This would work great. If I took and I made a line out like this, nice and straight, okay, like that. And then I said, okay, these lines extend, so you can imagine out, out here into the air, you can imagine that that comes right to that edge and that comes right to this edge. And so now you're going to be able to tell, when I write a number on here, you're going to be able to tell what it is. Now these are called extension lines. Extension lines. And it's lines that are literally drawn so that when I do this, okay, now I can put this in, I can put these two in like this. And now I can say, oh, that's 5 meters, okay? So you go, oh, okay. So these are extension lines. And what is this called? These lines also have a name. And these two are usually used together in conjunction with each other quite often. So extension lines, and this is called a dimension line, a dimension line. So it actually shows the exact length from one point to another. And the extension line enables you to sort of see that that's what we're actually looking at, is that bit right there, okay? Now, if I wanted to put dimension lines to show you how wide this wall was, I would go like this. Put this down here. And then if I wanted to show you the dimensions, how wide it actually was, there's two different ways that I could do it. So here I showed you the extension line and the dimension line. I want to show you something. Sometimes if this distance is wide enough to write inside, we use what we call inside dimension. Inside dimension lines. And they look like this. They come over here, and there's an arrow there, and there's an arrow there. And then we write the number in here, whatever it is. But here's the other interesting thing. In order to confirm that what we're literally showing you is the dimension from here to here, we use some type of an end on this dimension line. And this is called, it's basically a cut line. So this, they call them cut lines. So the dimension is shown by these two little lines. Now this one is called an arrow. Okay, arrow type. Arrowhead. And that would be an inside arrowhead. Now we could also do this, and you'd show your actual distance there. You could also show a line that comes over and a line that comes to here, and you could put a dot, and that dot would cover exactly the point where the exact point that you're showing is the dimension. Okay, and this one is basically just called a dot cut line. And another type that's quite popular, if you're showing the same dimension, comes up like this, out to the end, and then they show a slash that goes exactly through the point where the lines, meet. And this is just called a slash cut line. So arrowhead cut line, which is basically this whole thing represents all three of these are dimension lines. And this one has an arrowhead cut line on the end. This has a dot cut line on the end and a slash cut line. And they show you exactly where the dimension measurement finishes. Okay, so that's that. Now, what about if I have something like this and the space is too narrow to put you know, my dimension lines inside and write anything, okay? So now we use a different, and this is called an outside dimension line, outside dimension. And it looks like this. What you do is there, you've got your two sides of your piece, and I'm going to use arrowhead cut lines on this. And this is going to be an outside dimension line using arrowhead cut lines, okay? So if you can see that well, that shows you now. What have we talked about so far? Let me summarize. We looked at the, first of all, the visible, so visible line. Then we looked at the center line. Center line. And we looked at a hidden line. Hidden line. And we looked at extension lines. Extension. And after the extension, dimension. So this actually shows you the size of things, dimension line. Now, there are a couple of more to go, and so let's look at it this way. The next line that I want to talk about, I'm going to clear this out of the way so we can kind of get a better look without getting confused with what we already have. Let's say that I have an object. It looks like this. It's a piece of steel pipe, okay? And we have to actually take and weld a fitting onto here. And so we need a drawing of it, okay? So we have to weld this fitting onto this piece of pipe. And on the other end of this pipe, now here's the problem. This pipe is actually, in the real world, it's 12.5 meters long, okay? And I want to show it in a fairly good scale, but there's one of these at both ends of this. And so even to get it large enough so I can see what's going on, if I draw that whole 12.5 meters out, it's going to take up, 3 drawing sheets. So that's not practical. So what they say is, when a dimension continues without any change, we can go like this. And we can go here. And this is now the other end of this pipe. And we can say, okay, there's the matching fitting that has to be welded onto this one. Okay, now on this drawing, they're like this far apart, but this line that's right here basically cuts out. It cuts out everything that is unnecessary because there's no change in the dimension of this from one end to the other. And so these lines that we have here are called, they call them basically short and long break lines. Now they avoid using the word cut because cut line is the term that we used for whether we used an arrowhead cut line at the end of our dimension, or we used a dot, or we used a slash. Those were cut lines, okay? And so now we're going to use, instead of saying cut line, we're going to say break. Okay, it's a break line. It shows a break in the material. So we're not going to see the whole thing. So these are very useful in conserving space on drawings when you can sort of break away a piece that is just going to take a lot of space on your page. Okay, so break lines will cut away things that don't need to be shown. Now, we're getting close to the finish. And so what I want to do is I want to refer you now to the to this sheet that I gave you earlier. And let's take a look. There's a couple diagrams in here that actually illustrate a lot of them. You'll find these now that you know, and you start looking at these, you'll find these all over the place. So break, it's a break line that is used there. And so let's go ahead and let's look. And in here, there's actually an example, and it's down getting close toward the end on about page 39. And it gives you a really nice diagram with a whole bunch of the common lines on it. So let's take a look at that. They even show a couple that I haven't probably mentioned, but they show, oh, the other one, sorry, I used it earlier, and it was like this. It was, if I said this. Okay, so if I said, okay, there's got to be a 1/4-inch weld around that fitting, and look at that line that I put, and I put it so you know, okay, you know what, that weld's got to go right here, all the way around that, right? And so this is called a leader line, leader, and it leads you from the note to the specific location, leader line. Okay, so these are the mechanics, all right? This is just understanding, and it helps you. If you don't know what the lines mean, then it's a lot tougher when you start looking at it. But go ahead and look on page 39. You're going to see this diagram. At the top, it says visible lines are thick, continuous, bold lines. It shows you an object there. Hard to say exactly what it is, some manufactured object. And it shows you a whole bunch of the examples. And there's one more on here, actually, that I want to mention that I hadn't mentioned yet. You see the way that this pipe is cut at the end? It's actually, you can see it's cut. And what you do to show that an item has been cut is you put what we call sectioning lines on it. And these are called sectioning lines. And those sectioning lines are actually another type of line, sectioning line. And so they basically indicate that something has been cut. So you see it's an exposed surface that would not normally be visible, but you'll see this a lot. You'll see those sectioning lines shown on section plans. Okay, that's where you're going to see that. Things that have been cut away so you can see inside and see the inner workings of it, okay? But if you look at that, you're going to see starting at the top, they have dimension lines, extension lines, leader lines, sectioning line, break line, hidden line, center line, and the object line is what we would actually call a visible line, where it says object line. It's a visible line that shows that thing. There is another type of line if you want to superimpose or show another piece of equipment, in close proximity, and it's very similar to a center line, but it's a longer line and then 2 dashes. They call that a phantom line. Doesn't come up all the time, but you can see it's in there. That's nice to know as well. Now, we already talked about this earlier. See where it says cutting plane line? That's the line that I showed you earlier that would be used. That line would go between your 2 section reference symbols. So that cutting plane line looks like this, right? It basically looks like this. And this would be across an object wherever you're going to make the section. So for instance, this would probably be on a, on a floor plan, and you'd be indicating that there's a section here, and I could call this B, right? And so that type of line will indicate where the section is being cut away. Okay, so that's called a cutting plane line. Cutting plane. And I'm just going to put in brackets, that's for sectioning. Section plans. All right, now, there can be some variations on these things, but one thing that's nice is that when you, these are the kind of the basics of the line types. When you get to a particular set of plans, normally there is actually an alphabet of lines that appears in a schedule or a legend format to tell you specifically for that set what type of lines you can expect. Now the next thing that I'd like you to look at, which is pretty nice, is if you look at the diagram just below the just below the visible line diagram. You can see it right here. So take a look at that drawing at the bottom of page 39, and there you can see a whole variety of different lines. You can see a center line. I see a break line. I see leader lines. I see dimension lines. Lots and lots of different things included in there. Okay. The 5/8 offset that's shown there, what we would call that is an outside dimension line using arrowhead cut lines. Arrowhead cut lines, okay? All right, the next page, also page 40, a whole variety of different line types there. But the one that I want to point out to you here, and this is the last example of lines, and this is something that is very helpful for what we're going to be doing in another day or so. So let me get rid of this example. And let's talk about the last type of line. And it looks like this. So a set of plans will pretty frequently have this set up on it. And these lines may coincidentally line up with the edge of a building, or they might not. So, you know, you might have a building and this edge is actually the edge of the building, okay? But in a lot of cases, these lines, they're not necessarily a very heavy line, they're just a light line that's placed over, and these are called grid lines. Grid lines. And these lines are used heavily in the process of communication between the people that are on the site working, and basically if you need to communicate with the general contractor or the architect, what you can say is, yeah, I'm looking at a motor starter that is supposed to be mounted at, and let's see where it's going to be. Here's A, B, C, D, E, F, and here's 1, 2, 3, 4. And the motor starter is supposed to be mounted right here. But when I get to the field, I see that there's actually something that is in the way. So I need to talk to the architect about this and find out if there's going to be a deviation. Should we move it? What should we do? So you go, okay. Before I call him, like he's sitting in his office, he's got a set of plans, you know, behind him, and so you go, okay, you know what? I should figure this out exactly where it is, so that when I talk to him or I send him an email, he'll know exactly what I'm talking about. So okay, this starter is at A, B, C, D. Now it's not D and it's not E, and so what you do is you always divide between these into decimals. So I'll go, this starter is at a location that I'm going to call D.5 and 3. D.5 and 3. So what that means is D.1, 2, 3, 4, 5. And there's your 6, 7, 8, 9, 10. So this is at D, this is D, this is the 0.5, and this is 3. So that tells me, okay, I'm looking on the plans there, and then you can say, yeah, this is on the this is on in the basement, or this is on the second floor. And so this gives you an exact, because maybe there's 25 disconnects. You say, yeah, you know that motor disconnect? He's like, I had no idea what this guy's talking about. So what you do is grid lines like this give you the ability to pinpoint exactly what you're talking about when you're communicating. So very, very important concept, the grid line. And so I'll just give you a couple of more. What if I put some random thing yeah, about here, okay? And I go, you know, where is the center of this panel actually on the plan, right? So I go like this. Well, that's about the center, and that's about the center. So I'm going to say that's the center point. And now I'm going to go, well, that's at about B. I'm going to say B3. I'll be really close, right? B3 and 1.5. I'm going to say 1.7. okay, B3 and 1.7. And those are the grid, sort of the grid coordinates of where that thing is. And so you go, okay, you know, you could go on and on making examples of this, but as long as you understand the concept, the grid lines are laid out. And if you take a look at this example on page 40, let me just ask you this. What are the coordinates of the center of the entrance door to the foreman's office? The center of the entrance door to the foreman's office. So I'm going to give you a minute to look at that. And I'm going to go over here. I'm going to write a number on the board without anybody seeing. And then we'll see if it's the same thing, okay? And so this would be me giving you a call and saying, yeah, you know what, I got a question about the door to the foreman's office. It's at this place. So you guys are going, okay, I'm looking at my set of prints. Where's it gonna be? So I would say this. And it really doesn't matter which coordinate you put first, to be honest. But you do need to look at the number or the letter preceding to know whether you're going the right direction or not. So here's what I came up with, okay? Basically the center of the foreman's office door, I see it at C.2 and 1.6. So, you know, if you're pretty close to that, then we're both thinking in the same terms, all right? So you can do a little practice on this sheet based on that. And on the next page, page 41, I've also given you a couple more examples, random examples that I did. You can kind of just check those out and see if they kind of make sense to you in that way as well. Now, let me clear the board. That's the end of the mechanics of the drawing set, okay? And so what I want to do now is I want to give you a brief introduction, just a few minutes worth into the specifications. But specifications is a little bit like code, like I've said. So you wouldn't want anybody to give you a code video. So I'm not going to give you a specifications video. But what I am going to do is I'm going to supply you with a set of specs and a set of questions. And so we do need to get used to looking at the specs and seeing what some of the questions could be, what type of information is in there. But I do want you to look in your guide right now. And at the back, I've placed in a couple of pages that show the sort of the standard master format that architects use for laying out the sections of the specifications. And as you can see, there are a whole bunch of different sections. And as you go through them, everything from starting with the procurement and contracting requirements, general requirements. Then you have existing conditions, maybe at a site, concrete, masonry, metals, on and on down it goes. Now this has been expanded. This is the newest up-to-date standard. It's called the master format. This format doesn't use every section, so it's similar to code in that way. So there are some that are at this point not used, and they're going to be filled in as necessary with changes in technology and equipment possibly. So you'll see from 15 to 20 reserved for future use. Electrical, I think that you should know what section in the specs is going to deal with electrical equipment, and it's section 26. And if you look down to the end, there's some more reserved for future use, and it goes up to 48. So 48 different sort of divisions in the spec. The electrical, section 26. And if you look on the back page of this guide, I've given you a little bit of a breakdown as to what the specs are kind of used for. What's the idea of it? What does it show? And so each division in the specs is broken down into 3 pieces. And you'll see this as soon as you look into the spec that I give you. I'm only going to give you the spec for section division 26 for the electrical. The spec that I'm going to give you is the whole book is over 2,000 pages. The section that I'm going to give you is considerably less than that, but you just got to realize this can be an enormous book. There's a lot of things that you need to check and look at in there. But each division is subdivided into three different sections. The first one is general information, products, and under products, that would be exactly what must be supplied. And then execution, which is exactly how must this be installed, okay? So the spec is very, very detailed under those three categories. So I'm going to give you the spec document. You'll be able to download it from the handouts section, and then I'm going to give you some questions to work through. So that part, a little bit like code, but it's something that we need to take a look at and be aware of as well. Now, with that being said, it's really time for us to get to work and get some prints out. And for some of us, like myself, I'm going to have to put my glasses on, and we're going to get down to work and start actually digging through, looking for things, okay? It's like a little bit of a scavenger hunt. So I hope you like that sort of thing. All right, thanks very much for your attention. And now we need to just get to work.